Okay, what we're going to talk about today are compound probabilities again, but this time we're going to talk about when the events are dependent. Okay, when one outcome affects the other. Okay, so it says right here, the dependent events are events where the outcome of one event does affect the outcome of the other. Okay, so let's look. We had these cards yesterday. Let me make this closer. And we're going to use them again today. Okay, but the difference is that it says you draw two cards from the pile at the right, but you do not replace the first card. Okay, so let's talk about it. The probability that my first card is an A is 1 out of 8, right? There's 8 cards, there's one letter A. And then it says, I'm not going to replace it. What are the chances that my next card is a Z? Okay, so if this A card is gone, right, this A is gone, how many cards are the letter Z? There's one letter Z, but how many cards are left? 1, 2, 3, 4, 5, 6, 7, right? Because I took one away. So this is going to be 1 over 8 times 1 over 7. So 1 times 1 is 1, 7 times 8 is 56, and then I'm done. Okay, and these problems are going to essentially like reset every time. So we're back to 8 cards. So what's the probability that my first card is a gray card? 5 out of 8. Okay, so hypothetically I picked this E, so it's gone. So now what are the chances that my next card is an L? Well, there's only one L out of 7 cards left. So 1 out of 7. So now I get 5 over 56. Okay, and neither one of those can be simplified, so I'm done. Okay, and then this last one, what's the probability that the card I pick is a vowel? Okay, so A, O, and E. So that's 3 out of 8. Okay, let's just say I picked the letter A, so that's gone. So now, what are the chances that my next card is a K? Okay, 1 out of 7. So 3 times 1 is 3. 7 times 8 is 56. So did y'all see how that's different than yesterday? Yesterday, the denominator would have stayed the same, right? Today, these dependent events, the outcome of what you picked the first time impacts what the second one's going to be. Okay, so the next section says there are 1 dozen cookies on a tray, 6 chocolate chip, 4 sugar cookies, and 2 oatmeal. So what is the probability that you have a chocolate chip cookie, then a sugar cookie? Okay, and we're eating them. So, okay, or every problem's resetting. So you're not gonna take a cookie and put it back. So what's the probability that the first cookie if I just reach in there, okay, and pick one out, that my first one is a chocolate chip cookie? Okay, well it's 6 out of 12. That's my dog. Okay, so 6 out of 12, so half the cookies are chocolate chip. But now there's only 11 cookies left because Jack, stop. Now there's only 11 cookies left. Sorry. So, and 4 of them are sugar cookies. So what I'm left with is, and let's see if I can cross reduce anything first. What are 2 and 4 both divisible by? Hold on. Jack Bauer. Okay, so they're both divisible by 2. So 2 goes into 2 one time, and 2 goes into 4 2 times. So now what I'm left with is 1 times 2 is 2, and 1 times 11 is 11. Okay, so it resets. What's the probability that my first cookie is an oatmeal cookie? So that's going to be 2 out of 12. Okay, so now there's only 11 cookies left. What's the chances that my next one is chocolate chip? 6 chocolate chip cookies. Okay, I can go ahead and cross reduce, or I could even let's do this first. 2 out of 12 is the same as 1 out of 6. And then what do y'all notice is going to happen with these 6s? They're going to cancel. So I'm actually going to be left with 1 times 1 is 1, and 1 times 11 is 11. Right? And if you think about it, if I had multiplied straight across, I would have had 12 over 132, and that would have simplified to 1 over 11. Okay, what's the probability that I have a sugar cookie and then another sugar cookie? So the chances of me getting a sugar cookie on my first pick are 4 out of 12, right? And I'm gonna go ahead and write 4 out of 12 as 1 out of 3. Okay, I went ahead and simplified it. Sorry, this is getting a little jumbled up. And then what's the probability that my next one is a sugar cookie? How many sugar cookies are left? Only 3, right? Because I picked one for my first drop. So I can go ahead and simplify. 3 and 3 can become 1 and 1. And I'm left with 1 times 1 is 1. And 1 times 11 is 11. Okay, then the last thing we have to do is talk about whether events are independent or dependent. So if we were to toss a coin, okay, and then roll a number cube or a dice, does the coin affect the number cube? No, those would be independent. Okay, what about if I picked a card out of a stack and then I put it back and then I picked another card? What do you think? Okay, that would be independent, okay, because it doesn't matter what I pick on the first one because I'm putting it back. So it's gonna go right back into the stack and you have the exact same cards to pick from as I did, okay? Down here on this last one, you select a card, you do not replace it, and then you select another card. That's dependent. Okay, if I had 10 cards and one of them said $1 million on it, oh my gosh, Jack. Okay, if I had 10 cards and one of them had $1 million written on it, okay, if I picked the $1 million card first, would that affect your chances of getting it next? Yes, right? So dependent because I did not replace it.